Now, just make it maybe a little bit stronger on the top.
Let's look out.
Good?
Put all four of the things on.
So the first most important thing is he gets himself out, and the second thing is to figure out how he can get the motorcycle out.
5 seconds is actually a pretty long time. How long do you think it's going to take to pull the string and the basket up?
Integrating Engineering and Literacy, or IEL, is a project we have. It's funded by the National Science Foundation. And the premise is that teachers will pick books and the students will go through and try and mine problems that the characters are having, and then design and build something that the characters could use in the book.
So the thing goes this way, and then it would pull the thing so it turns on, and then the voice thing would say like something like, "Go away, this is my lunch." Yeah.
The idea is not that there's a set number of books or type of books that they're supposed to use, but that this is a way of teaching, a way of approaching literature and engineering that you could use with any books.
They're all working in teams and they have to figure out those dynamics.
It would be better if we had one hole here.
How to work together to do these problems.
Peter's little brother from the book tries to eat his turtle, and we designed a cage to keep his brother out.
I think we should use kind of my idea for the trigger, because the lock is probably just going to be one of the ones that you flick up and you open, or maybe no lock at all. You just open the latch and open the box.
Breakfast was a very quiet affair. Nobody had much to say. Mr. Yarby drank 2 glasses of Juicio. "You know, Dad," I said, "I only drink Juicio to be polite."
Problem weird.
Because all of a sudden, engineering is really supporting the literacy because the kids are using the book to find the clients and the problems that they're working on.
We're solving the problem that people couldn't take a shower or bath, and we solved the chick problem, and we also have another thing that solves the chick mesh.
And the story, what happened is because they had the food on the bottom and the chicks would swim around, they couldn't actually take a shower to be stepping on the food and whatever else was in the tub.
It's a chick flick. You just flip the chick and flick it in. Okay. And that's all you have to ever do.
The camp really gives us a chance to explore all the things that are hard to do in a classroom.
We are trying out a lot of strategies and technologies that we're going to try to support in the classroom next year. Just like that, so you can see the whole thing. That's great. Now do you want to smash it while she's watching?
I pointed at Fudge and he pointed at me. My father picked out my brother and carried him up.
The goal here is to see how this would work in real classrooms with real teachers who have expertise of their own, but they have to work it into their school day, into their school year with all the constraints they have.
Oh, we did it! What just happened?
I'm gonna redo it, okay? I didn't even get half of it.
If something doesn't work, you can go back and fix it, and it's not a big deal.
The kids in school don't always get this opportunity to fail, and that's totally expected in engineering.
You couldn't get up, because Ralph did. Let's try it again. Let's do it again. Okay, let's do this again.
We can see what they're doing while they're planning, so we can see the whole arc. So that's valuable data for us, so that when we talk to teachers and try to support them next year, we can merge with their expertise to create really good projects for kids.